All right, hi folks, hi everyone. We'll get started in just a few minutes. Thank you for joining. Let me share my screen.
And plus I finished the 10.8 homework as well.
Nice work, Gennaro. Thank you for working ahead.
Yep.
And I'm gonna bring up our calendar. And I'll bring up this section 10.3. And, oops, I meant 10.4. Oops. All right.
We don't start until like about 5 minutes.
Yeah, we're going to start in 5 minutes. Yes. Folks, anyone have any questions while we're waiting? Any WebAssign questions? So I'm going to bring up the chapter 10 summary also.
Oh.
Section 10 for today. And then you could see on this Sunday, there's 2 homeworks due, the 10.3 and 10.4 homework. Folks, remember, these homeworks are kept open until May 1st with no late penalties, but please try to stay on schedule. I know you have other courses you might be taking and other responsibilities that you have, but to the best of your ability, please try to keep up with our schedule here for MATH026.
And plus like so it'll be 15 questions on the chapter 10 test then.
Yeah, so next week, folks, we're going to cover our last section, which is 10.8. And then next Friday, we'll work on a practice test for chapter 10. Due by next Sunday is the test on chapter 10. That's 15 questions. As Gennaro mentioned, you'll take that in WebAssign. And then our last week is the week of April 27th. We're just going to spend that doing a practice final exam.
So we'll be reviewing for a final exam like the entire week then.
Exactly. Yes, that's right. Okay. All right, folks, anyone have any questions on section 10.4 so far? Anything else from chapter 10? Any WebAssign problems causing you trouble in any way? Folks, just a reminder, if you get stuck in WebAssign, please remember that you can use that Ask My Teacher button for any of the homework problems. That sends me a message, and then I can see exactly the problem you were working on. So please feel free to use that button anytime you get stuck. All right, folks, so remember the idea here in this section is we want to be able to graph these polar equations. And you might say, why do you want to graph these anyway? What's the point of graphing polar equations? Well, there's a lot of applications where you want to see a visual picture of what's happening as you vary an angle and what's happening to these r, comma, theta points. Let me give you a quick example. You might so here were the different kinds of graphs we were talking about. So when you graph these polar equations, you could end up with these graphs that are either circles, cardioids, rose curve, and so on. And here's slide 8 that shows you what some of these polar curves look like. For example, a cardioid has this shape, it kind of looks like a heart. there are these loops. If you look here at inner loop limison, it has this loop to it. And then we talked about these other kinds of curves. Lemon skate kind of looks like a figure 8. Rose curve, it almost looks like the petals of a flower, and so on. One example that comes to mind is if anyone does any kind of sound recording, if you are using a microphone, like a studio microphone, cardioid is actually the graph that describes what's called the frequency response of a microphone. And it just shows you how sensitive the microphone is depending on where the microphone is placed in relation to the speaker. You might think about the microphone and the angle between the speaker. And so there's a graph. If you buy any microphone, you'll get a graph that looks like a cardioid. And it's showing you you can think of it as like the accuracy of the speaker, of the microphone, I mean, the accuracy of the microphone in relation to the location of the speaker. There's a lot of examples where these polar graphs come into play. All right, so here's what we said, is if you want to graph a polar graph like r equals 4 cosine theta, let's say. Okay, so here's a polar equation, r equal 4 cosine theta. There's a couple ways you could do it. The long way would be to make up an r comma theta table. So let's say we want to graph this r equal 4 cosine theta. What I could do is make up an r theta table. Sometimes I draw it as a vertical table like this. And I can come up with some different angles. Notice here I'll use 0 degrees, pi over 6, pi over 4. I'm going to write these in degrees just to make it a little easier. Let's say 0 degrees, 30 degrees, 45 degrees, 60 degrees, 90 degrees, and so on. So I'm listing out all of these arbitrary choices for theta. So these are arbitrary, meaning you could pick these angles to be anything you want. Then for r, I would plug in and figure out r equals 4 cosine theta. So for this first row, it would be r equals 4 times cosine of 0 degrees. But you might remember cosine 0 is 1. So this is the answer 4. All right. How about for the second row? The second row would be r equals 4 cosine 30 degrees. Well, cosine 30 degrees is the square root of 3 over 2. So if I was to work this out on my calculator, 4 times the square root of 3 over 2, I would get the answer of about 3.46. Let me do one more. What if we were using theta equals 60? Well, that would be r equals 4 cosine 60. But cosine 60, you might remember, is 1/2. So this would be 4 times 1/2, which is 2. So what this is giving me is all of these different r comma theta points. From this row, I'll call it row A, we came up with the r theta of 4, 0. I'll call this row B, we came up with 3.46 comma 30 degrees. And we did one more example, I'll call it row C. We came up with the answer 2 comma 60 degrees. And I could keep going and come up with more and more of these r theta points. Now I could go plot each one of these on the polar graph paper. So I'm going to go plot these. All right, let's do 4 comma 0 degrees. Well, this would be this red dot right here that I'm putting on the graph. Let me go to 3.46 comma 30 degrees. Let me plot that as a blue dot maybe. All right, so I'm going to go to 30 degrees, which is about this radial line here. And I'm going to go out to about 3.5. So that would be this blue dot right there. All right, let me go to 260 degrees. I'll plot this maybe in purple. So I'm going to go to 60 degrees, which is about here. Walk out a distance of 2, and there's the purple dot. So once I do this for many, many angles theta, I'll end up with these dots. And then I would connect these dots with a smooth curve, and you can see I end up with a circle here for this particular equation. Okay, so one way to do this, I guess you would call this the long way, is to make up your own r theta table, come up with any arbitrary values of theta, calculate r according to the equation you started with. That gives you many, many r theta points that you can go plot, and then you would connect the points with a smooth curve. You might remember this is exactly the way you would graph in rectangular coordinates. You remember you make up your own xy table if you were graphing an equation like y equal x squared, let's say. Okay, but you can see this is very tedious, and this would take you a long time. So we have a better way, or a shortcut. The shortcut way is to go to slide 8 and match up the equation you're trying to graph with one of these equations. And there's two pages of these summaries. So I would either look at this page, slide 8, or look at slide 9. Match up the equation to one of these options. That will tell you the type of curve. You know, as an example, if my equation that I was trying to graph was r squared equals, let's say, 16 cosine 2 theta. Well, that matches up to this kind of a graph right here, to this kind of an equation, I should say. What if I had an equation that was r equals 5 cosine 8 theta? Well, notice that would match up to this equation, because notice it says n is even. In my example, n here was 8, right? Notice the format is n theta. So my n is 8, so this would be a rose curve. All right, now once you know the type of curve, then there are more detailed slides to go to help you figure out the exact orientation of the graph. Let's say, for example, our equation matched up to a cardioid. Then I would go to slide 13 to get a more detailed view of different cardioid graphs. So this slide is telling you the different orientation of, you know, whether the graph, for example, is on the right side here, on the left side, on the top, or on the bottom. Okay? So the idea for graphing is we don't really want to graph these by hand. We really want to take the equation that I'm given and match it up to one of these libraries to allow me to determine the shape of the graph. All right, so let's go do some WebAssign examples. I think we did some last time, but let's finish up. Let me do one or two examples that we did already just to remind you the setup. So let me do this example here on slide 17. I think we already did this one, but let's review it quickly. So it looks like for this example, the polar equation is r equals 4 plus 4 cosine theta. Okay, I'm going to go back to slide 8 as my starting point. So I'm going to slide 8. And I want to see if this equation matches any of these templates. All right, well, first, I know it's not a circle because my equation doesn't match this format, so it's not a circle. Now, in order for me to match up to either cardioid or one loop limison or inner loop limison, what I have to do is kind of write this in the format of A plus B cosine theta, because I want to match it up to these templates here. When I do that, I'm seeing A is 4 and B is 4. So in our example, A matches up to 4 and B matches up to 4. All right, the other thing I want to do now is I want to calculate this A over B quantity because I want to know which category do I fall in. So let me come over here to the right. It says A is less than B. Well, we don't match that because our A is 4, our B is 4. So our A is not less than B. All right, let me also calculate A over B to help out now. Well, A over B is just 4 over 4, but that's equal to 1. So I can see that's a match here to this condition that says A over B equals 1. So I know our graph is a cardioid. But what does the cardioid look like? So now I go to the next slide on cardioids, happens to be slide 13. And now I'm going to match up my equation to one of these 4 options. So let me try to match this up to one of these 4 options. Okay. Well, remember our equation is 4 plus 4 cosine theta. Well, the only match you could see is this graph A. Right? I know graph C is no good because graph C involves sine theta. Graph D involves sine theta. But our graph involves cosine theta. Also, our equation has a plus sign in the middle. That rules out graph B because graph B has a minus sign in the middle. So I'm left with the answer of this leftmost graph, which means the cardioid is oriented on the right side of the graph paper. So that gives me the answer I need. I go back to the WebAssign example. We know our graph was, we know our graph was.
I can't see the screen.
Oh, sorry about that. I must have clicked the wrong button. Bear with me one second here. Let me get back to screen sharing. Whoops, I'm going. There we go. Okay. So I'm back to screen sharing. And again, we figured out that our graph was a cardioid. And we also figured out that our graph was oriented on the right side of the polar graph paper. So that gets us to that answer choice. All right, folks, so let's go and do some examples that we haven't done yet. So let me jump to some examples. I think we did this one last time. Let's come over to this one. I don't think we've done this one yet. All right, so remember, WebAssign is going to give you an equation and then ask you to select from a multiple choice of 4 possible graphs. All right, so I'm going to write down this equation to start with. So it's the equation here is r squared equals 64 cosine 2 theta. All right, let me go back now to slide 8. Okay. And I'm trying to match up our equation to one of these templates. Well, you can see it doesn't match to any of these because all of the equations on this slide have an r equals. But our equation is r squared. So no good here. Let me go to slide 9. I'm going to slide 9. Okay. Well, I'm noticing that our example is cosine 2 theta. And that matches the left side here, right? So I'm seeing here our example is cosine 2 theta. Well, that matches these equations with 2 theta. And also it has an a squared in front. Well, that means our a squared is matching up to 64. So RA must be 8. I guess we could say plus or minus 8. All right, so I know the graph now. The graph is a lemon skate. Kind of looks like a figure 8. Or you might say it looks like an infinity symbol. All right, so I'm not ready to answer the question yet because I need to know the orientation for this figure 8. Is it horizontal? Is it vertical? So let me go to a supplementary slide for lemon skates. And I'm going to scroll down. Looks like slide 21. Okay. By the way, folks, all of these graphs are on the Chapter 10 summary. So let me show you the Chapter 10 summary just to emphasize that all the formulas that we need for Chapter 10 are here on this Chapter 10 summary. So let me just show you that law of sines is here. Law of cosines. Here's how to convert from polar to rectangular. And then here are the graphs that we're talking about. And then here are all the details extracted from the slides, okay? So you don't have to memorize any of these graphs. You have them available here on the Chapter 10 summary. All right, well, let's go back now. We got to figure out which one of these choices match up to our equation, okay? Well, I know that our example, our equation involves cosine. So that means I'm going to cross out choice C here because choice C uses sine. Same thing for choice D. Choice D involves sine, but our graph is a cosine. Also, should I go with choice A or B? Well, choice B has a negative sign in front, but of course our graph doesn't have a negative sign. So our graph must match up to orientation A. So it looks like it's a horizontal figure 8, so to speak, right? So it's this horizontal lemon skate. Okay, so now I know the orientation. I'll go back to the WebAssign question. And so now we can answer this one. I know our graph was a lemon skate. So that's the type of graph. And we know our graph matched up to this horizontal orientation. Okay, makes sense, folks? Everyone okay with this setup of figuring out the correct graph here? All right, well, let's do a couple more WebAssign examples. This way you can work through some of these yourself. Let's do a couple more of the more complicated examples. So let me go to slide 24. All right, let's take a look at this one. It says R equals 6 cosine 2 theta. All right, so let me write down this equation. R equals 6 cosine 2 theta. Okay. And I could see the choices they're giving me, by the way. They're showing me either a lemon skate here, or a lemon skate here, or a rose petal here, or a rose petal here. Okay. Now remember, I could figure this out myself by making up an R theta table if I wanted to. Right? I could pick arbitrary values for theta, plug it in this equation, and figure out the corresponding value of R. But of course, I don't want to do it that way. I want to come up with a more efficient way to do it. So let me go ahead and go back to slides 8 and 9 as my starting point. All right, let me go back to slide 8. All right, well, I'm noticing that none of these equations on slide 8 match up. right? Because again, our example is 2 theta, but none of these equations involve 2 theta. So let me go to slide 9. All right, well, for slide 9, let me see what is matching up. Well, you know, I'm noticing that in our example, we are given 6 cosine 2 theta. All right, now I'm going to rule out this graph on the right-hand side. Because even though this does match up to r equals a cosine n theta.
Plus, like it said here, says like it's r squared equals a squared and cosine theta. But here we need a r equals a cosine 2 theta.
Exactly right, Jannar. Yeah, here's the point, folks. Notice for this graph, n is odd. So that means the number in front of theta has to be an odd number. But that's no good. Rn is a 2, which of course is even. So no good for this graph. How about a lemon skate? Because a lemon skate does have 2 theta here. But notice this would have to be a squared, meaning it's got to be a perfect square in front. So what this is telling me is the number in front of a squared, the number in front of cosine 2 theta has to be a perfect square. It's got to be some integer squared. So for a lemon skate, it might be an equation, for example, like r squared equals 9 cosine 2 theta. Or it might be r squared equals 16 cosine 2 theta, or r squared equal 25 cosine 2 theta. Can you notice all these numbers in front are perfect squares, meaning they represent some integer squared. But that's not what we have, because we have the number 6. 6 isn't a perfect square. I can't write 6 as an integer squared. So it means the lemon skate is out, because my equation really doesn't match up to the a squared part of the lemon skate equation. Well, that leaves me with just a rose curve. And I could see I do match up, because our equation does match up to a cosine n theta. Well, in our example, then a would be 6, and n is even, right? N equals 2. So that means n is even. So that matches up. We match that condition. And now what this is telling us is you should expect there to be 2n petals. Petals are like these separate leaves coming off the graph. For example, in our example, there's 1, 2, 3, 4, 5, 6, 7. There's 8 petals on this diagram. On this diagram over here, there's 5. See, I'm just counting them up. So this diagram over here on the right is 5 petals. Well, notice it says 2n. But in our example, n is 2. So that means we should expect 2 times 2 petals. So our graph has to have 4 petals on it. All right, so let's go back to the WebAssign question. We know it's going to be a rose curve, and we know it should have 4 petals on it. So let's go ahead and go back to that diagram. Let me clear the screen. Okay, let's go back to the WebAssign question. All right, here it is. So we just figured out that our answer has to be a rose curve. So I know this is the correct typograph. And also we know it has to have 4 petals on it. Well, I know it's not this choice because this is a lemon skate. I know it's not this choice. But how do I know now whether to answer in the upper right-hand corner or the lower left? How am I going to figure out which one of those 2 graphs is the correct choice? Anyone have any ideas or thoughts about trying to figure out how we could decide between these two choices? Well, to help me decide, how about if I make up my own little r comma theta table? And I really don't have to come up with too many lines in this table. I really only need one or two lines in order to rule out one graph or the other. Well, let me pick one example. How about if I pick theta being 0 degrees? That's usually an easy angle to work with. So I'm going to pick theta equals 0 degrees. All right, well then r is 6 times cosine 2 times 0 degrees. But of course, 2 times 0 is 0, so this is 6 cosine 0 degrees. Does anyone remember what is cosine of 0 degrees? Anyone remember cosine 0 from the unit circle? Let me draw a quick reminder of the unit circle. Here's the unit circle. I'll mark 0 degrees with a blue dot. Here's 0 degrees. But I know that point is 1 comma 0, right, in XY notation. I also remember the x coordinate is the cosine. So what this is telling me is cosine 0 degrees is equal to 1. All right, so that means this is going to be r equals 6 times 1, which is 6. So this r value is 6. Okay, so I have 6 comma 0 degrees as this r comma theta. Well, let me go plot 6 comma 0 degrees. I would rotate 0 and come up, go out a distance of 6. So this blue dot is 6 comma 0. This blue dot down here is 6 comma 0. Well, now I can see the answer. This graph in the upper right corner can't be correct because it doesn't have a point plotted at 6 comma 0 degrees. So this has to be the correct answer here because it does have a point plotted at 0 degrees. Let me give you one more example because maybe you don't like working with 0 degrees. Let me come up with another easy angle to work with. So let me come up with another line in this table. Now, for me to pick an easy value of theta to work with, let me notice that inside the parenthesis here is 2 times theta. So what that means is I'm going to pick a value for theta so that when I multiply it by 2, I get an angle that's on the unit circle to make it easy to work with. Well, I know working with 90 degrees is an easy angle to work with. So, or I could work with, let's say, 60 degrees. So here's what I'm thinking. I know that cosine 60 is equal to 1/2. That's an easy angle to work with. I know that cosine 90 is equal to, let me plot a point, here's 90 degrees. Well, that's 0 comma 1. So I know cosine 90 is 0. So either one of these values would be easy to work with. So how about if I work with, let's say, cosine, why don't we do cosine 60? But that means I want to come up with theta equal to 30 degrees. Because remember, I'm going to take 2 times theta. So let me write here, r equals 6 times cosine of 2 times 30. Okay. Well, that's going to be r equals 6 times cosine 60 degrees. Right, and again, I selected 60 degrees to make it easy to work with because I know cosine 60 is 1/2. So this is 6 times 1/2. Cosine 60 is 1/2. This is going to be 6 times 1/2 is 3. So what we just came up with is when theta is 30 degrees, r is 3. So let's go plot this point that says r equals 3, 30 degrees. Okay, so let me come up to this graph in the upper right-hand corner. Remember, each one of these slices is 15 degrees. So if I want to go to 30 degrees, it's going to be this radial line. Let me do it in purple. Here's the radial line that represents 30 degrees. Then I'm going to go out a distance of 3. So this purple dot is 3, 30 degrees. But notice it's not falling on the graph. So again, this tells me that this graph is not correct. Let me go down to this lower left corner. Again, I'm going to go out to the angle 30 degrees. Here it is in purple. I'm going to walk out a distance of 3. So this purple dot is the point 3, 30. And notice it does fall on the graph. So again, that tells me that this graph is correct. All right, folks, so this example is a little more complicated than some of the others. We did narrow the choices down to either this graph A or this graph B. But how do we figure out whether to select graph A or B? What we did is we just picked 1 or 2 arbitrary values of theta, plug it into the equation, solve for r, and then go plot the corresponding r theta point on the polar graph. And that should let you eliminate the wrong choice and zero in on the correct choice. All right, everyone okay with the setup on this one? All right, folks, let's do there's one more example here. Let's come to this one. These are pretty graphs, by the way. So let's take a look at this example. It's r equals 4 sine 3 theta. All right, so here's our equation. R equals 4 sine 3 theta. All right, well, as usual, I'm going to go back to slides 8 and 9. You could probably guess it's going to be a rose curve because all the choices are rose curves, but let's go back to slide 8 and 9 anyway. Here's slide 8. Well, I know my equation doesn't match up to slide 8 because my equation is 3 theta. None of these examples here are 3 theta. Let me go to slide 9. So I'm coming here to slide 9. And I know it's not going to be a lemon skate because the equations for lemon skates are based on 2 theta. So it's not going to be this kind of graph.
It's going to be a rose curve.
It's going to be a rose curve, but let me go to this middle choice. This middle choice says n is even.
But we have 3 theta, not 2 theta.
Exactly right. In our example, n is 3.
So it should be 3 is odd.
3 is odd. You got it. Exactly right. So that means this graph is no good. So that tells us it's going to be a rose curve. And notice it says n petals. So our graph has to have 3 petals on it. Okay? So let's go back to our example and try to figure out the correct choice now. So we know it's going to be a rose curve, but it has to have 3 petals on it. Okay? So first of all, we know it's a rose curve. Okay? And it has to have 3 petals. Well, again, I know this is out because this has more than 3 petals, so the upper left is no good. The upper right is no good. Again, it has more than 3 petals. But this lower left, I'll call it graph A, is a possibility. And down here in the lower right has 3 petals also. So I'm down to graph A or B. So I need to figure out which one of these choices is correct.
The one on the left is correct, the A.
And Gennaro, how did you come to that decision?
Because like here it's like it's going, it's here is facing down when it's going 4 right here. 4 for each side.
All right, well, why don't we do this? Because we need to decide between these 2 choices. How about if I make up a little r comma theta table? Right, because if I could graph 1 or 2 points, that should allow me to eliminate the wrong answer and focus in on the correct answer. Okay, how about if I pick 0 degrees again? Because 0 degrees is always easy to work with. So if I pick 0 degrees, this is going to be r equals 4 times sine 3 theta, 0 times 0 degrees. That's going to be 4 times sine of 0. And that's going to be 4. What is the sine of 0? Anyone remember sine 0? Let me go back to the unit circle. Here's the unit circle. And let me mark 0 degrees with a red dot. Here's 0 degrees. That's the coordinate point 1, 0. So what is sine 0 then? Well, remember the sine is the y value, so it looks like sine of 0 degrees is 0. So this is going to be 4 times 0, so r is 0. But when I plot r equals 0, theta equals 0, that's a point right here in the center of the graph. But both of these graphs have that value, so that's not really helping me. So I'm going to need another option. Does anyone have any idea of what I might do here to help determine which one of these 2 might be the correct graph? Anyone have any thoughts? Well, how about if I pick another arbitrary value of theta? But again, I want to be smart about this because I notice inside the parenthesis is 3 theta. So I'd like to pick a value of theta that if I multiply by 3, I get an angle that's easy to work with on the unit circle. So how about if I pick, let's say, theta equal 20 degrees? Or maybe it's even easier to pick theta equal 10 degrees. Let's pick theta equal 10. The reason I pick theta equal 10 is then I'm going to have sine of 3 times 10, which would be sine of 30, which I can easily work with. All right, so let's work out this second example here. So I'm going to come over here and work out r equals 4 times sine 3 theta, but we're using theta equal 10 degrees. So that's going to be r equals 4 sine 30. Anyone remember sine of 30 degrees? If I come over here to the unit circle, at 30 degrees. You might remember this dot is square root of 3 over 2 comma 1/2. So the sine of 30 is 1/2, right? All right, so I have 4 times 1/2, so r is 2.
I mean, if to get 2, you have to do 4 times 1, then divide the bottom.
Yep, and if you do that, you would get 4 divided by 2, so r is 2. So that means we have the point 2 comma 10 degrees, which should show up on our diagram, on our graph. All right, so let me try to figure it out. Well, 10 degrees, you might remember each one of these slices is 15 degrees, right? So each one of these pizza slices or each one of these sectors is 15 degrees. So I want to go up though to 10 degrees. So let me try to draw in purple a radial line that's at about 10 degrees. Of course, I'm just going to kind of eyeball this, but this purple line is about 10 degrees. This purple line is at about 10 degrees. Right? I'm trying to make it just a little lower than the 15-degree line. And now I'm going to walk out a distance of 2. If I walk out a distance of 2, let me draw the purple dot here. And let me draw the purple dot here. Based on my purple dots, would you answer with graph A or B? Remember, the purple dot has to be on the graph that they're giving us. Well, if you look at graph B, my purple dot doesn't fall on the graph, right? No good. My purple dot is not on the graph, so graph B is out. How about graph A? Yeah, graph A looks good because my purple dot is falling on the graph. So the answer here is this bottom left corner is the correct graph. And again, this is a little more challenging than some of the other examples because even though you knew this graph had to be 3 petals, there were 2 answer choices that had 3 petals. So I had to come up with another step to try to distinguish between these 2 choices. And so what we did is we came up with these arbitrary values of theta, and we figured out the corresponding value of r, plotted a couple of points on the graph, and when you do that, it should eliminate one of the choices that don't match up, and it should match, of course, the correct choice. Anyone have any questions? Examples? See, some of them are going to be a little more involved. Some of the others might be very straightforward, but a few of them might be a little more complicated, where you might have to pick a couple of theta values in order to determine the correct answer. Folks, anyone have any WebAssign questions from section 10.4?
I got a question. I'm gonna do the practice test so far since I finished all the chapters.
Okay, yeah. Jannar, if you have any questions on the practice test, please email me or we'll go over that next week as well.
Okay.
All right, folks, if you have no questions, feel free to log off. Thank you for joining. Hope you have a good weekend. Remember, if you get stuck on any problems, email me. I think I've given you my phone number, but let me give it to you one more time just so you can either text me or call me over the weekend. Here's my phone number, 610-217-5843. Feel free to call anytime. And then on Monday, we'll start our last section of the course, which is section 10.8. All right, folks, thanks for joining, and then I'll see you on Monday. If anyone has a question, I'm going to stick around for a few minutes to answer any questions that might come up.
Okay, buddy.
All right, see you on Monday, Gennaro. Have a good weekend.
See you later.
Okay.